Alright guys, so we're going to finish off the 2.1 and 2.3 lesson. Most of the stuff from today, actually all of the stuff from today comes from 2.3. So if you're getting a little confused, maybe you want to open your book to 2.3 and kind of reread that or rewatch the video. This stuff gets a little bit heavy, but it's actually not really very mathy. You're probably going to feel like you're more in an English class or a science class even than math. So just bear with us and try to get as much of this as you can, and then we'll go back over it a little bit tomorrow to help review you. Because we skipped 2.2, there's just a couple of things you need to know that we will learn in 2.2, but there's a reason we switch things around, I promise. So when it says hypothesis and it says P, the hypothesis, we're going to have these sentences that say if blah, 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 then blah, blah, blah. So the hypothesis is actually everything after the word if. So like in this case, in the World Series, we don't need that. If a team wins 4 games, that's going to be your hypothesis. I totally know how to write. Hold on. Okay, so their hypothesis is the stuff after the word if. It's sandwiched between if and the comma. And then the conclusion, well, if they win 4 games, what happens? So the conclusion is everything after the word then. Well, if a team wins 4 games, then the team wins the series. Okay, so if a team wins 4 games, then the team wins the series. So that's our conditional statement, and we'll learn that in 2.2. All you need to know for now is everything after the word if is a hypothesis. Everything after the word then is the conclusion. So here our hypothesis is a team wins 4 games. The conclusion is that the team wins the series. You can tell that that's a very general statement. Any team can do this any year, any time. So the law of detachment always starts with a general sentence that just says, if this, then this. So this is a very general statement. It's not specific. But then what happens, then we're given a given. So here is our given right here. It'll come directly next. So the given is, I really hate this app. The given is the Red Sox won 4 games in 2004. Okay, that is a very specific sentence. It was the Red Sox and it was in 2004. So, but see how it matches the hypothesis? The hypothesis is the general. Any team, anytime can win 4 games. The given is very specific. The Red Sox won 4 games in 2004. But they say the same thing. A team wins 4 games. Hypothesis is a general statement and the given is a very specific statement. So if it follows this order, general hypothesis, general conclusion, specific given statement, then you're going to just write this specific conjecture that follows that. Well, then what happened? Well, the Red Sox won the 2004 series. Okay, so what you want to look for with law of detachment, your hypothesis and your conclusion together should be a very general statement. If blah, 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 then blah, blah, blah. If that happens, then the next sentence should be a repeat of that sentence, but in a specific terms. A team wins 4 games, then the team wins the series. The Red Sox won 4 games in 2004, so the Red Sox won the 2004 series. If you go in this order like it says, exactly the same, general, general, specific, specific, then you will have a valid law of detachment. Okay? So one more time, your hypothesis and your given statement. See if I can get a different color here. The hypothesis and the given statement, they should say the same thing, but the hypothesis should be in a general format and the given should be in a specific format. And then if that happens, then your conclusion and your conjecture should say the same thing as well. But the conclusion is in a general way and the conjecture is in a very specific way. Okay, so that's the law of detachment, and we're going to follow that in the exact same pattern with these next examples that we do. We're going to hope it works just as beautifully as that one does. Okay, so if the side lengths of a triangle are 5, 12, and 13, then the area of the triangle is 30 centimeters squared. This got a little out of whack here. This little triangle symbol should be right there. If the area of triangle PQR is the area of triangle PQR is 30 centimeters squared. All right, so hypothesis. We said hypothesis is everything after the word if. So side lengths of the triangle are 5, 12, 13. The conclusion we said was everything after the word then. So that would be the area of the triangle is 30 square centimeters. So here we have a general statement. Hey, if you have a triangle that's 5, 12, 13, then the area of that triangle will be 30 centimeters squared. Okay, the next statement that sits by itself, that is going to be your given statement. So here is our given right here. Area of triangle PQR is 30 centimeters squared. Now, this is a specific statement because we're talking about a particular triangle PQR. It's not general anymore. It's specific. So, the statement that they are trying to get me to write would be the side lengths of triangle PQR are 5, 12, 13. Okay, so up here in the hypothesis and the conclusion, we have it in a general way, and then down here in the given and the conjecture, we have it a specific example. Now, the problem here, there is a problem. This is not valid. The problem, remember, when you look back up here, the hypothesis and the given are supposed to say the same thing. A team wins 4 games, the team wins, or the Red Sox win 4 games. But that's not what we have here. We have the side lengths are 5, 12, 13, and it's supposed to come down here and it's supposed to match, it's supposed to match the given. But those don't match. They're flippy-floppied. So that's why it's valid, because what we have is we have P to Q. We have P to Q is true, and then we are given that Q is true. And if you look on your formula chart for law of detachment, that's not what we're supposed to have. We're supposed to have P to Q is true, and then Q is true. So this is out of whack. It's out of order. It doesn't match what it's supposed to, so it does not work. Okay, so that is law of detachment. One more time. It's a general statement, if blah, 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 then blah, blah, blah. Then it should be a specific statement in the exact same order. If blah, 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 then blah, blah, blah. Okay, so if the specific statement is out of order, these two should be flipped, then you got to say it's not valid. No good. Okay. All right, law of syllogism. So take a second to read that in your vocab chart. So that one says P to Q and Q to R, then we can go P to R. And that sounds really confusing, but it's not. I call this the bridge law because we're going to use Q as our bridge. Okay, so there's going to be a middle connector who's going to be repeated. This is just like if I told you with regular math. What if I said 2 plus 3 is equal to 5? And then I told you, hey, you could also write 5 as 1 plus 4. See how this is connected in the middle, these 5s? So wouldn't it also be okay to then say, hey, well, if that's true, then doesn't 2 plus 3 equal 1 plus 4? And you'd say, yeah, for sure, because they both equal 5, so I can use those interchangeably. And that's what we're going to happen here. There's going to be a middle sentence that's going to be able to be used interchangeably. Okay. All right, so let's look at what we're saying here. And if you have 3 colors, the 3 colors might really help you here. All right, so I'm going to start and I'm going to say if something is a poodle. So that something is a poodle, I'm going to call that R. Then it is a dog. Oh, I messed that up, didn't I already? Okay, hold on. If something is a poodle, that's my first part. I'm going to call that P. So just so I don't confuse you. Okay, something is a poodle, that is P. Then it is a dog. So that's Q. Hey, looky here. Something is a dog. Well, I already talked about a dog, right? So if I already use Q for dog, then I'm going to use Q for dog again. Then it is an animal. So I'm going to call animal R. So you can tell from this statement we're following the pattern that I'm supposed to follow. If something is a poodle, then it is a dog. If something is a dog, then it is an animal. See how that works? So the dog is the same in the end of the first sentence and the beginning of the second sentence. So it can be kind of like collapsed. It's like my bridge. So I can now go directly from P straight to R. I don't need the bridge in the middle. So if I go straight from the beginning to the end, I can say if something is a poodle, then it is an animal. So all you're doing with the law of syllogism is you're cutting out the middleman. In this case, the middleman is talking about the dog. I don't need him anymore. I can go straight from if something is a poodle, then it is an animal. Same story with the second example. We're still doing law of syllogism. So if a number is divisible by 2, that's P, then it is, then it is even. We'll call that Q. If a number is even, well, I already talked about even, and I called even Q over here, so I'm going to continue to call that Q. Then it is an integer, so I'm going to call that R. So we can see that this follows the law of syllogism because the phrase that's in the middle, the end of the first sentence and the beginning of the second sentence is the same. It is even, it is even. So I can cut that middleman out. So let's rewrite our sentence. If a number is divisible by 2, it is an integer. Okay, so I follow my law of syllogism. I don't need to talk about this even business anymore because he got cut off. So I can go straight from beginning to end. If a number is divisible by 2, then it is an integer. Okay, so for this last example here, we're actually going to put the law of syllogism and detachment together into one big guy here. All right, so here we go. If a team wins 10 games, that would be our P. Then they play in the finals. That's our Q. If a team plays in the finals, that's Q again. I already talked about Q. Then they will travel to Boston. So that will be R. So right here, just in this first part, I'm already following the law of syllogism. P to Q, Q to R. So that means Q is my middleman, and I can cut him out, and I can write a sentence just going straight from P to R. So I'm kind of going to go on the side and do that. So if a team wins 10 games, they travel to Boston. Okay, so that's my law of syllogism right there, and I've shortened that down. Team wins 10 games, they travel to Boston. Okay, so now let's come over here, and now we have our given statement. Remember given from a couple examples ago? So our syllogism, now that we're done with that, this statement right here is a very general statement. If any team can win 10 games, then that team will travel to Boston. So now I have a specific statement. The Ravens won 10 games. But do you see how the Ravens win 10 games? That matches with my hypothesis. Remember, that's what it's supposed to do. Those first two are supposed to match together. So now I can make a very specific conclusion about the Ravens. Well, then the Ravens will travel to Boston. So I have general. If any team wins 10 games, they will travel to Boston, and then to specific. Hey, the Ravens won 10 games. Well, then the Ravens will travel to Boston. So this is valid because I followed the syllogism and I followed detachment exactly like I was supposed to, and everything worked out perfectly. So this is syllogism and it's detachment. We use both laws together, and I use them appropriately, so I have a valid conclusion. Okay, same story for part B, so y'all pause right here and try to do B. Remember, you're going to do syllogism and detachment all wrapped up in one pretty bow. Okay, so here you can see I follow the law of syllogism. Sum of two angles is 180 is my P. Angles are supplementary is Q. If angles are supplementary, that's Q again. Then they are not the angles in the triangle, that's R. So I eliminated the Q's, the middleman, and right here I wrote my general sentence with law of syllogism. The sum of two angles is 180. Then they can't be the angles in the triangle. And just mathematically, remember that a triangle adds up to 180. So if I already have two angles that are 180, I don't have room for the third one, so it wouldn't work. So that's what this sentence is talking about. So syllogism works perfectly for my general sentence over here. And then I can come here and I can see that now I'm talking specific. Angle A is 135, angle B is 45. Well, those two angles, angle A and angle B, they do equal 180. So that must mean that angle A and angle B cannot be the angles in a triangle. So that's my law of detachment. I take my general sentence here and I match it up with my very specific sentence here, exactly in the same order. And that worked out perfectly. Both syllogism and detachment were followed nicely. So I have a valid conclusion. Okay, so make sure you write your summary and make sure you have a lot of stuff in the margin, those extra kind of things that I talked to you about, because that is what is due for your homework tomorrow.